this problem from motion of a projectile, right? And the problem is a particle is projected with a velocity whose horizontal and vertical components are u and v. Generally, in some case, the velocity are given. We have to write the component along x-axis and y-axis. But in this problem, the component u and v are given. Okay, so no velocity required. From a point in the medium whose resistance per unit mass is k into velocity. So this is the motion of projectile in resisting medium, where resistance is equal to k into velocity, that is mkv. Prove that if the k is small, this k is very small, the range of the horizontal plane through the point of projection is approximately given by this. We have to find the horizontal range. Generally, it is denoted by capital R. Draw a rough sketch of this motion of the particle. Let it be x-axis and it is y-axis, and O be the point of projection, and the projectile is given by like this. Okay, and let it be A, and OA, this is the horizontal range we have to find out. Let the particle strike at A at time t equal to capital T. Okay, and in this point, this is A, the coordinate of A is r0 because this is in x-axis, and we let this is x-axis and this is y-axis, and initial velocity component is u here, and initial velocity component in this direction of y, this is v. Okay, let at any point p, this is the velocity, this is the velocity v. So resistance is k into velocity per unit mass, where m is 1. So the resistance force always acting backward direction, k into v. Let the coordinate of p is xy, and here another force mg always act downwards, and let this is the horizontal direction, and let it make with v is psi. Okay, and we extend this horizontal direction backward. So this is also psi, this is also psi, and the component of kv along negative x-axis is kv cos psi, and this is pi by 2 minus psi. So the component of velocity or component of force, sorry, resistance force along downward direction is kv sin psi. Cos of pi by 2 minus psi, this is sin psi. Now we write the equation of motion of the particle at any time t. Here time is t at any point t xy is given by x double dot. This is equal to minus kv cos psi, because kv cos psi act negative direction of x-axis, and this is also can be written as k into ds dt. This is velocity ds dt, and this is cos psi. Cos psi means dx ds, because we know that in differential calculus cos psi is dx ds. So we get x double dot, this is equal to minus k into dx dt, so minus k into x dot, right? And we get d dt of x dot by x dot, this is equal to minus k into dt. This dt is transferred to right side, and integrating we get this is log x dot, this is equal to minus kt plus c1, integrating constant, and we use initial condition at O. at O t equal to 0, x equal to 0, y equal to 0, x dot equal to u and y dot this is equal to v. All are the initial condition. They are given in our problem. So we get this is log u and this is 0 plus c1. Okay, so we get log of x dot by u, this is equal to minus kt. That is x dot, this is equal to u into e to the power minus kt. And we integrate this relation one more times. We get x, this is equal to u into e to the power minus kt by minus k plus c2. And also using the initial condition, we get x equal to 0, t equal to 0. Then we get c2, this is equal to u by k, because e to the power 0 means 1 and this is 0, so c2 is u by k. And we get x, this is equal to u by k minus u by k into e to the power minus kt, that is x, this is equal to u by k into 1 minus e to the power minus k. This is our first relation. Now we take the second equation of motion along y-axis. This is negative y-axis. All the force act negative y-axis. This is mg, this is minus kv sin psi. And we take here this is g only, because we consider all the forces per unit mass. And the second equation of motion is y double dot, this is equal to minus g minus kv sin psi. Okay, and this is minus of g plus k into ds dt into sin psi means dy ds, and this is minus g plus k into dy dt, so this is y dot. Now if we write dy dot by g plus k into y dot, this is equal to minus dt, and we multiply both sides by k and integrating we get this is log of g plus k y dot, this is equal to minus kt plus c3. Okay, now here we use the initial condition. This is y dot, this is equal to v, t equal to 0, and we get c3 equal to log of g plus k into v. And by putting the value of c3 here, we get this is g plus k y dot by g plus kv, this is capital V, it is given, and this is equal to e to the power minus k. Okay, that is g plus k into dy dt, this is equal to g plus kv into e to the power minus kt. Now again integrate this relation and get gt plus ky, this is equal to minus 1 by k into g plus kv into e to the power minus kt plus c4. Okay, now here we again use the initial condition, that is t equal to 0, x equal to 0, y equal to 0. Here y equal to 0, t equal to 0, and t equal to 0 means e to the power 0, this is 1, so we get c4, this is equal to 1 by k into g plus kp. And putting this value of c4 here, we get the relation as this is gt plus ky, this is equal to g plus kv by k into 1 minus e to the power minus k. Okay, this is another relation. with t and y, and this is a relation with x and t. Okay, this is named as 2. Now here it is not required, but if we wish to find the path of the particle, okay, in this motion, then we must eliminate t from 2 and 1. Then we get the path of the particle, that is the equation of the curve using x and y. We have to eliminate t from 1 and 2. Okay. Now we get two important relation, this and this. Also there are another two important relation, this is and another is this. This is okay. These four are important relation and these two are equation of motion. The first is this and the second is this. This is y double dot. Okay. This marking part are very important for further calculation. Here we have to find the horizontal range. We already let that horizontal range is r, and when the particle is at a, that is when x equal to a, x equal to r, sorry, not a, x equal to r, then here t equal to t, we already laid here, this is the time t equal to capital T, and in this case y, this is equal to 0. So we put x equal to r and t equal to capital T in 1 and y equal to 0 and t equal to capital T in 2. This is 2, right? And we get the relation r, this is from 1, r equal to u by k into 1 minus e to the power minus k into capital T. This is the first relation and it comes from 1, and the second relation is g into capital T plus k into 0, because y equal to 0, and the right side is g plus k into v by k into 1 minus e to the power minus k. This is the second relation. Sorry, this is capital P. Okay. Now we eliminate capital T from this and this, and we get gt. This is equal to g plus kv by k into, this is k r by u, because 1 minus e to the power minus kt, this value is like this. Okay. Now we have also to be put here the value of capital T. What is the value of capital T? We find from here. Okay. Now 1 minus e to the power minus kt, this is equal to k r by u, and this is given by 1 minus this, and taking log on both sides, we get minus k into t. This is equal to log of 1 minus kr by u. So the value of t is given by minus 1 by k into log of 1 minus kr by u. Okay, and we put the value of capital T here. We get the relation as minus g by k into log of 1 minus k r by u. This is equal to k cancel out, r by u into g plus k. Right? This is the relation of r and k, u, v, etc. Okay. Now we expand this series log of 1 minus x, and this series is given by minus g by k into, this series is given by minus kr by u. The first term is kr by u, and the second term is minus k square r square by u square into 2, and this is 2u square. Okay, and third term is minus kq r cube by 3u cube, and so on. And this is g r by u plus, and this is the second term is r a v by u. Okay, and we take common k from this relation and take common minus 1 also, and get g into r by u plus k r square by 2u square plus k square r cube by 3u cube, and neglecting all the other term of this series because a is very small here. Okay, it is given that a is very small, so we neglect all the other term. And also if we take on u from this relation, we get this is only r, this is 2 by u, this is 3 by u square, right? And this is 1 by u into gr plus r a v. We cancel out u from both sides and get the relation as, and if we multiply g with this relation, then the first term is gr, the second term is g k r square, and the third term is g k square r cube by this, and this type is, we cancel out the first term gr from both sides. We get the relation g k r by 2u plus g k square r square by 3u square. This is equal to r k v, and 1 r is common from the right side. Now we cancel out the r from the both sides. G k r by 2u, this is equal to kv minus g r square k square by 3u square. Okay, and we multiply 2u right side and dividing by gk, we get r, this is equal to 2kuv by gk minus 2u g r square k square by 3u square into gk, right? Now here we put in this term only r equal to 0 by taking the first approximation of r, because here it is given that the approximate value of the horizontal range, we have to find the approximate value of r. So we put r equal to 0 in this term to get the first approximation of r, that is to get first approximation put r equal to 0 in right hand side. Okay, r is, we get r, this is equal to 2kuv by gk, that is kk cancel out, so r, this is equal to 2uv by g. This is the first approximation of r, right? Now we put the value of this r in the second term, that is in r in the right side. We get the final approximation and we get the final value of the horizontal range as r, this is equal to, we put r is 2uv by g in here, and the first term is same as the above, 2uv by g, this is the first term, minus 2u, g cancel out, k cancel out, 2uk by 3, 2uk by 3u square, that is 3u, u also cancel out, into we put the value of r square as 2 uv by g whole square, and this is given by 2 uv by g into, take common 2 uv and get 1 minus, this is 4 k uv by 3 ug. Okay, and sorry, okay, right, this is u cancel out, then our result is exactly same as the given result. So the final result or final approximation of r is given by this 2 uv by g into 1 minus 4 kV by 3g. This is the given result, or this is required result.